Hola, hello, good morning to everybody. Thank you for coming for this presentation. My name is Vicente Segura. I work in Telefónica, TCCT, and I'm leading the OT and IoT security value proposition. Today we am here with Unai Ayúcar from Alias Robotics, and we both will present this presentation, which is about challenges and solutions for industrial cybersecurity. So let's start with the challenges. First of all, I like to use this slide to depict the context in which we are in. We are in a digital transformation process, as you all know, and it's composed of a set of digital waves of transformation that started several decades ago. First of all, with IT systems that changed business processes inside companies, bring your own device, movement to the cloud, and now we are in the IoT revolution. Particularly for industrial cybersecurity systems, industrial systems, what it's doing is exposing more and more industrial assets and infrastructures. And what that is doing is to increasing the attack surface of the industrial companies. In Gartner's view is represented in this slide. As you can see, they see the industrial systems evolution is going from fully air-gapped OT systems towards newly designed and engineered cyber-physical systems. So there has been a set of transitions in that process, which is a dynamic or hugely dynamic process. And what I want to do is to explain in the next slides how is this process affecting cybersecurity? How is this bringing new risks? So if we move back to the end of 90s, industrial architectures were like this. You have two networks, office network and production network. The particularity of this architecture is that they are air-gapped, they are separated. They are physically and logically separated. The fact is that in such an environment, it's very difficult to exploit the vulnerabilities that you may have in the production network. In fact, in the production network, you had different technologies and communication protocols, very proprietary and so on. But this started to changing. If we move to the 2005, 2010, there is a huge transformation in the production network that what is doing is that the different automation cells that you have in the production network are increasingly interconnected among them. The Ethernet, TCP/IP starts to be the most important technology, communication technology, inside the production network. And that makes that if you infect the engineering equipment, it's easy to spread a malware inside the production network. This continues changing, and a moment arrives in which office network and production network start to be interconnected, thanks to the fact that they both have TCP and IP and Ethernet communication as the main communication technology and mechanisms. So here we are seeing how the attack surface is increased. You had remote accesses that have the potential to reach the production network. You also have systems in the office network, which are in red, that connects both networks. These are dual-homed servers that facilitate reaching the production network from the office network. And here was the main cybersecurity risks start to appear, right? And now we are in a situation, we are talking about factory of the future, Industry 4.0. We are introducing new technologies like 5G and so on. And the funny thing is that most of our customers ask, is 5G secure? Is this bringing risks? But in my opinion, the real issue there is that most of the companies don't have clear knowledge about what they have in their legacy environment, in that production network or office network. And now you are integrating both environments with the risks of exposing the vulnerabilities that you have in legacy environments. So what we are seeing is an increasing number of incidents that affect industrial companies that are able to reach those production networks due to the fact that there is an increasing convergence between OT and IT. So from our experience, what we can say is that we have found this group of challenges among industrial companies, depending on their security maturity, the level of maturity they have. Those companies that are not really highly mature in cybersecurity, the problem they have is that they don't know what they have in their environment. They need to understand what they have in their production network, if they have remote access, if they have equipments that are exposed, and so on. Once they have that clear and have defined a cybersecurity plan, medium-term challenges start. Which kind of cybersecurity solutions we can deploy to improve that situation? And finally, those companies that have already started deploying this kind of solutions are facing long-term challenges, introducing new technologies like 5G, digital twins, and so on, and they need to start defining security requirements and solving those requirements from the very beginning, from the scratch. So let's move now to the solutions. What we are doing, what is our particular view, what kind of solutions we can offer. First of all, we use this diagram in order to explain what we can do or what should be the process to increase the security, the maturity, the level of maturity of a company in terms of cybersecurity. First of all, it's really important to assess and plan. We need to know what do we have, what risks we are exposed to, and so on, and define a cybersecurity plan. Once you have that clear, implement security solutions, and finally, make good use of those solutions, managing them properly. We will explain several solutions we have and how we make this process. First of all, regarding the assessment and plan, what we propose here is to making an assessment, a security assessment, both technically and from a compliance point of view, so that let you know how are your infrastructure, which assets do you have there, which vulnerabilities are exposed, which cybersecurity requirements you should meet, and then you plan a cybersecurity roadmap. We have explained this in publication that you have there, which is open. You can download this paper. This is a summary of what we can offer with these consulting services. This is a report based on an analysis of the infrastructure that the customer has in their industrial environment. Basically, what we do is a theoretical analysis, but also a practical and technical analysis based on analyzing the traffic and using tools that are able to provide visibility on the assets that you have, how they communicate between them, what kind of vulnerabilities they have, and so on. So you get information like this one, number of IT systems, OT systems, if there is passwords that have been found analyzing that traffic, if there is malware activity, if there is something that is not properly configured, and so on. With that in mind, we start implementing solutions. And this is a roadmap, a proposed roadmap of the solutions that would be good to deploy. First of all, we start with the knowledge. We have made that assessment of the infrastructure, and we have planned what we want to deploy, which is what starts in point number 2. First of all, protection. This is the most important part, properly segmenting office network from production network, and also properly segmenting OT networks. We have highlighted there, with blue, in blue color, those solutions for which we are going to make a demo in the following minutes. After you have that protection, you start doing containment, particularly with endpoint protection and another set of solutions that we have identified there. Then it's very important to monitor. Monitor allows to make a continuous detection of potential incidents and react and respond properly to them. It's a fact that using only protection mechanisms is not enough, because threats are very dynamic. So you have to have detection mechanisms to have a proper cybersecurity strategy. And finally, manage and optimize what you have deployed. So let's move now to the demo. It's a video demo where we will show the segmenting and segregation solution and also the monitoring. First of all, in the video, you will see a very simple environment that we have simulated in order to how this environment can be exploited and how can we detect and block those incidents. You have here a robotic arm which is writing something in a paper. And as you will see, it's in a simplified industrial environment where you have a PLC that controls the robot and SCADA system that supervises everything, an engineering station which has the program that controls the robot operations. In such an environment, is the first thing an attacker would do if he reaches the OT network is to launch a scan using solutions or tools that are available like Nmap. With that scanning, the attacker is able to identify the different devices that you have in the network and also the services that those assets expose and the kind of protocols they use and so on. So the attacker launches the Nmap solution, and has information about the different devices. He finds that there is an SCADA and PLC, and now he will launch a man-in-the-middle attack. Man-in-the-middle allows to fool both extremes so that all the traffic goes through the attacker's computer. Once he has access to that traffic, as that traffic typically is unencrypted and doesn't require the authentication of the ends of that communication, he's able to see all the traffic, identify assets, and vulnerable versions of the different solutions. He finds that the SCADA has a vulnerability, and now he's launching an exploit. That exploit allows him to get critical information like secret formulas and particularly passwords. The password of the engineering station. With that password, he is able to access the program that controls what the robot is doing. And as you will see, the robot starts writing a different thing. Or at the end, what this shows is that he has tampered the manufacturing process. Well, how can we block this? We have now an architecture where we have introduced a next-generation firewall, which is able to filter all the traffic that goes between the SCADA system and the PLC. Blocking that kind of solution allows to block specific protocols, specific malware, and at the end, blocking this kind of attack. We also have introduced an IDS specialized in OT, which is Nozomi in this slide. And as you will see, it is able to detect the man-in-the-middle attack that we have used to make this incident. As you can see there, we have detected that attack. But this is technology. On top of that, we need to put something that allows that the technology is used efficiently and effectively. And this is where our main capabilities come with the SOC. We have implemented a SOC managed service layer in our SOCs that allows to simplify and make more efficient the use of this technology, using two particular technologies, CM for correlating and aggregating events, and also the SOAR for orchestrating and automating responses, so that we can filter the kind of incidents we receive and assess them to see if those incidents are relevant, and in that case, send a notification to the customer and help them to respond and recover in case that there is an impact for that incident. And now we will move to the third solution we want to show, which is RIS from Alias Robotics. So Unai, the floor is yours.
Hello. Yep. So thank you so much, Vicente. It's always a pleasure to share a stage with you. So, well, as he said, I'm Unai from Alias Robotics. I'm the CTO. I'm in charge of all the solutions that you will see here today that somehow bring together the last piece of this big puzzle that we are showing with Telefónica. Basically, we are a company that its main action is cybersecurity for robotics. How does this come with the solutions that Vicente was explaining? At the end, on those shop floors, on that industry that we were placing, there are always robots or components that go at the end of this network, which we try to cybersecure and to analyze. Basically, a little bit about us. We were born some years ago, and we have done several things in the past. The most important one here today is the partnership we have with Telefónica to resell our product, and also other activities related to showing cybersecurity for robotics around the world, with activities such as CS4R, also done with Telefónica. Basically, we started being a company that was more as a hacker than as a security solution provider. We started hacking robots. We started learning about them. We needed to know what was the market so that we could actually implement solutions for them. And we realized it for different robot brands, different manufacturers, that we encountered more than 1,000 vulnerabilities over those systems. Actually, those vulnerabilities, some of them are public in the RBD, which is a public tool, as there are many others in the world for different kind of vulnerabilities, that allows you to know which is the situation of the vulnerability status of those robots. I bring here a video today, but don't worry, because I think that we are going to be able to connect afterwards with my colleague in Vitoria, because we are from Vitoria, and I think that we are going to be able to do also a hack in live. But first of all, for you to see here, this is kind of important for us. You have here, excuse me, now. You have here three kind of different robots. One of them, it's an AGV, which goes on the shop floor. It helps in logistics. And as you can see, the safety system is completely compromised. On the left side, for me, of the screen, you have a collaborative robot, which is the one below, which is the most sold one in the market, and also an industrial one. We are doing a ransomware to both of them. It's not just that we wanted to do a ransomware, it's just a proof of value that it's possible to be done. So just imagine in companies such as big automation companies, in which those stops imply more than 12,000 euros per minute. So these ransomwares are a specific tackle for robotics, and it can imply a lot of money for different companies. Alias Robotics has two types of approaches for this kind of problems, and it brings together with the solution that Vicente was planning. So basically, you see here the same map. What a surprise. We are in cybersecurity, and we are doing the same as everybody does. We do first analyze, then assess, and try to help, and finally mitigate and restart again. This is called the DevSecOps cycle, and it's done for anyone that is trying to do cybersecurity around, because basically helps to, first of all, identify which are the vulnerabilities into a system, assess those vulnerabilities, and clearly set up some techniques to mitigate them, and finally start again once and over the whole system. This is our portfolio of services, which goes from the threat modeling to pen testing and consulting for helping companies into the robot cybersecurity world, and also in shop floors together with Telefónica, so that we can identify those vulnerabilities that may affect to the systems. As Vicente was perfectly pointing, it is not that important, the point of having a vulnerability in a system or the network you are connecting it to, but actually knowing what you have in your system, in your shop floor, in your factory. Basically, we have different kind of robots. One of them were put there 40 years ago, and the other ones came yesterday. We have to assess and understand which is the difference between the robot that was put there 40 years ago and the robot that we are putting today. Because technologies also adapt, and the way attackers can see those robots is different. One of them has protection by default, or should have it, because it's new, but the other one was just left there, and it's also connected to the network by other means, but it's connected. So we have to understand which is the situation for that company. Basically, what we did was, okay, we have found a lot of vulnerabilities. We understand that the market is unsecure. So we proposed RIS. RIS is an antivirus, an endpoint protection platform. Basically, it goes installed in all of the robots. We have support for different brands, and it acts as an antivirus for, such as the one that you have in your computers. It generates different elements around the robot, such as intelligent firewalls, artificial intelligence also running to detect new anomalies. It could be similar to that solution that Vicente just showed, but for the overall network. But it goes installed in each of the robots. Let's try now to connect with my colleague, because he's going to do a hack demo from Vitoria with two robots. One of them has RIS installed, and the other one no. he's going to launch the same attack for those two robots, and let's see what happens. Let's try to connect with him. Let's see. Indica?
So many thanks, Unai, many thanks, Vicente. Hello, Barcelona. It's a pleasure to be here today. So we've prepared today a short industrial demo where you'll see a robot without robot immune system installed that is operating over there, and a robot with our robot immune system installed. So first thing we'll do is we'll pick up the robot screen. You'll see that our robot is operating and RIS is totally installed, showing the teach pendant interface in this case. And now we'll proceed to launch two attacks on these robots. The first one will try to disrupt operation of the robot bearing robot immune system. We see that the robot remains normal and the operation is not altered, whereas if I try it on the second robot, the attack is successful, and almost instantly what we observe is that the teach pendant is disrupted. So the robot is now rebooting and will shortly arrest and stop the industrial process. This is not done at the very same moment because of the details of the particular attack that we are implemented, but this is up to the maliciousness of the cyber attacker. So this is just one particular example of a robot being hacked live, and the industrial process which it's operating, which can cost up to millions per calendar day, is now compromised. Now, if you provide me with extra 2 minutes, I will provide some other attacks using the physical attack vector, in this case with a USB.
Okay, so I think that I have to give him 2 minutes. He's going to prepare another attack. One of the big issues, I'm sorry, I know I'm less interested than having hacks at robots in real life, but well, I'll try my best. Basically, what you were seeing in the teach pendant of the robot is that's the solution, that's RIS. It goes installed directly to the teach pendant. It's a really easy, usable interface. It has a training system. It goes, trains itself, and then learns over all the environment. So it does not need anything more. It's somehow plug and play. And basically what Indica is preparing right now, it's an attack that is a physical attack. So one of the problems of these systems is that they are not only vulnerable for network attacks, but they are also vulnerable to physical attacks. USBs, different elements that you may have in your factory that operators go without intention, plug, and suddenly the robot gets stopped, or any worse consequences. Let's see if we have Indica. Yeah, they are telling me they are ready, so let's try to connect again with them. Okay, let's go. Okay.
So
yeah.
We are right back, this time with the crafted USB that has got our own malware inside. So we have prepared this proof of concept, and we will be showcasing in the robot bearing, the robot immune system. If we insert this USB, you will see how the attack is completely stopped. The operator receives a notification of the danger that has been prevented by the robot immune system. Now we can proceed to resolve this danger alert, and we can resume back to normal operation. You see the robot is not actually impacted, and the industrial process keeps on being resilient and works perfectly fine. Whereas if we try this very same attack on the second robot operating over there, you will see instantly how this malware is being disrupting with the robot operation and with the robot controller in particular. So you see how the teach pendant is completely going mad, and the industrial process is arrested, and the whole robot gets encrypted and is just left as paperweight. So this is what we had today prepared. I recall back you the connection, Unai and Vicente, and thanks very much.
Well, thank you, Endika. As you have seen, there were two kind of attacks to a robot that can be in any shop floor, in any industrial shop floor. And basically what I wanted to tell you also today is that we have collaborated with different companies. You have some of them there, and we will do some announcement this year to show you how these solutions do interoperate with others that already exist. We are not competing with anyone. Security is a process, and each of the elements should be secure so that we can ensure security overall. It has to be in the network level, it has to be in the robot level, and it has to be in all the levels, as it is in IT areas, in which you have your computer with your antivirus, and you have also a firewall and a router which is well configured, and all the systems. Basically, what we see here, and this is our proposal together with Telefónica, is that we have all that kind of environment in which we have an IT area, we have a demilitarized area in which supposedly is the change between the IT and the OT, where the factory is. And basically we have solutions, such as it can be Nozomi, such as can be any other. Vicente can explain much better than me because he's the expert here. And finally, we should put also the solution for the robots, which are the endpoints in our network. And by the way, it has been proven that they may be the most dangerous part or the most affecting part to hack those companies, as they are the older ones without less updates. Basically, I have here just a client of us, which is an automation company that already trusts in us, but I wanted to handle Vicente the control again, and thank you to all the time here today.
Thank you, Unai. Thank you very much. So just to conclude, as a high-level view of how to deploy these solutions that we have shown here in an environment, very simplified environment, of course, that represents the factory of the future, where you have a factory ecosystem. You can have different factories, a corporate ecosystem that connects somehow those different factories, that receives all the information that is being produced regarding the manufacturing process in the factories, and also the integration with third party, which is about the cloud services and platforms that you can have in public clouds. So what do we propose here? First of all, understand all the picture. That's the reason in the bottom you have that professional services, consulting, assessment, and also pen testing, so that you have an end-to-end view of everything that you have. Then you have the factory ecosystem, where both legacy and also new generation environments will live. They will live for a long time, because legacy environments won't be discarded very, very soon. They have to live with the new environments. So in data picture, you need endpoint protection, especially for those devices that are directly connected to platform, and also monitoring solutions for those networks so that you can monitor the traffic and detect potential incidents. And of course, to segment and segregate properly those different environments, you need a perimeter protection, those new generation firewalls that are able to filter the traffic, so that you can create segments, so that those devices that do not need to connect directly you can filter, block that kind of communication, and block in that way lateral movements if an attacker is able to reach any of those critical environments. So this concludes our presentation, and thank you very much for the attention. And now, if you have any question, more than happy to answer.
Thank you so much.
Thank you very much. Any question you may have? So again, thank you, and have a good day.